Good morning, students. Myself Venkatesh. Today we are going to talk about a deadlock concept. In previous class, we have studied about what is a deadlock, what are the various necessary conditions for deadlock characteristics, and at the same time, what are the system models comes under deadlock, and the methods for handling deadlock. See, in methods for handling deadlock, we are going to talk about deadlock prevention. What is deadlock prevention? Simply, and what is deadlock avoidance, deadlock detection, and recovery. And after that, we have studied in detail about deadlock prevention concept. Now, in this class, we are going to concentrate on deadlock avoidance and deadlock detection and recovery. Okay, so before going to see deadlock avoidance and deadlock recovery, let us see what is a resource allocation graph. See here, a resource allocation graph, or we can say RAG. It is the most effective, efficient, and convenient way to represent the state of the system. In our system, how the resources are allocated to the process, how the processes has been assigned to the multiple resources. To represent that, we are using the resource allocation graph. In this resource allocation graph, we are going to see how the resources are utilized by the process, how the process is assigned the resources, like that. Deadlock can be described more precisely in terms of a directed graph called a system resource allocation graph. Okay, we are going to, in order to represent the deadlock situations, we are going to use the resource allocation graph. In our system, whether there is a deadlock or not, to represent that, it is the most suitable method. Okay, if a system, whether it is deadlock is there or deadlock is not there, whatever it may be, in order to represent whether it is deadlock or not in the deadlock position, in order to represent that one, we are going to use the resource allocation graph. Like normal graphs, it is having two things, that is vertex and edges. Okay, in the vertices, there are two types of vertices are there: process vertex and resource vertex. Whenever the number of processes in our system, all the processes are representing with the vertex. They are generally presented with circles. Okay, whatever the resources like CPU, register, memory, or monitor or printer we have in our system are represented again in the resource vertex and represented in rectangle. Okay, if it is circle, means it is a we can say vertex, or circle means vertex, rectangle means it is a resource. Then resources are two types, that is single instance and at the same time multiple instance. In our system, there can be a resource which is only one, precisely only one, single, only single, we can say single. Then it is a single instance resource, for example CPU, monitor. Some of the resources which is multiple present, they are in multiple numbers, then it is a multiple instance. Okay, just like as a register. At the same time, edges also represent two types, that is assigned edge and at the same time request edge. Assigned edge means we have resource is connected with the process. There is a edge which is moving towards the process, means that resource is assigned to a process. At the same time, if the arrow going towards the resource, if the arrow is going towards the resource from the process going towards the resource, then we call it as request edge, that is P requesting resource. Okay, like no, this is the assigned edge and request edge. Next one is process, and in this diagram we have process and resource. Okay, this is the first representation is process is requesting for a resource. Okay, we are going to represent the arrow like this, and the second one is resource is assigned to a particular process. Okay, so see, resource is assigned to a particular process. Okay, this is the representation of the process and resource allocations. Okay, so next one is coming to deadlock avoidance. Okay, next one is deadlock avoidance. Okay, after completion of deadlock prevention, okay, and we are going to talk regarding deadlock avoidance. We are trying to give the resources to the, in this deadlock avoidance we are going to try to give resources to the process, and whatever we give the resources to the process, we will check whether it is safe situation or not. When we give the resource to the particular process, we check whether the deadlock can be avoided or not. For every resource allocation, we check the safe or unsafe situation. This is done by the Banker's algorithm only. Banker's algorithm resolve the problem of deadlock avoidance also, whereas it requires the system has some additional prior information available. Simple and simplest and most useful model requires that each process declares the maximum number of resources of each type that may be need. And one more thing is deadlock avoidant algorithm dynamically examines the resource allocation state to ensure that there can be never be a circular weight condition. In this one, there is no situation of circular weight condition. The resource allocation state is also defined by number of available and allocated resources also. Okay, so this is the deadlock avoidance. At the same time, we are going to talk about safe state. See, what is meant by safe state? When a process request an available resource, system must decide if immediate allocation leaves the system in a safe state. A system is in safe state if there exists a sequence, that is P1, P2 and so on Pn, of all the processes in the system, such as of each Pi, that is the resource that Pi can still request, can be satisfied by currently available resources plus resource held by all the Pj, that is process Pj. That is, if Pi resource needs are not immediately available, then Pi wait until all Pj have finished. At the same time, when Pj is finished, Pj is one process, Pj is finished, Pi can obtain needed resources, execute, return allocated resources and terminates. Okay, so when P1 terminates, next Pi plus 1 can obtain its needed resource and so on, like that. Pi plus 1, like that. If a system is in safe state, means there is no concept of deadlock. If a system is unsafe, means possibly of deadlock. Okay, avoidance means ensure that a system will never enter into the unsafe state, means okay, trying to keep it always unsafe state. Okay, next one is we have avoidance algorithms that we can say in avoidance a single instance of resource type, that is in this one we are going to use a resource allocation graph, whereas multiple instance of resource type, in this one we are going to use the Banker's algorithms Banker's algorithm. So resource allocation graph algorithm comes under these majorly avoidance algorithms are two types. First one is single instance of resource type, multiple instance of resource type. In the single instance of resource type, we have resource allocation graph algorithm, whereas multiple instance type we are having Banker's algorithm. So in this resource instance single instance of resource type, we are going to use the resource allocation graph algorithm. So what is meant by resource allocation graph algorithm? Here the majorly edge Pi implies Rj, indicates that process Pj may request resource Rj represented by dashed lines. Okay, at the same time claim edge convert to request edge when a process requests a resource. Request edge converted to an assignment edge when the resource is allocated to the process. Okay, when a request is released by a process, assignment edge reconverts to a claim edge, and a resource must be claimed priorly into the system. Okay, this is regarding resource allocation graph. So next, coming to the deadlock detection. Okay, so what is meant by deadlock detection? Okay. So in this deadlock detection, if deadlock prevention and avoidance are not done properly, as deadlock may occur, and only thing left to do is to detect and recover from the deadlock. There are two important concepts in this category. First one is wait for graph and next one is Banker's algorithm for deadlock detection. Okay, in this wait for graph, it is an enhanced version of resource allocation graph in which we do not show the resources. Okay, in this one we have single instance. After this wait for graph, we are going to talk about single instance of each resource type. Okay, so if all the resources have only one, if only single instance, then we can define a deadlock determination algorithm, deadlock detection algorithm that uses a variant of resource allocation graph called wait for graph. Okay, we obtain this graph from the resource allocation graph by removing the resource nodes and collapsing the appropriate edges. Okay, most precisely, an edge from pi to pj in a wait for graph implies that process pi is waiting for process pj to release a resource that pi needs, and edge pi implies pj exists in a wait for graph if and only if the corresponding resource allocation graph contains two edges. Pi implies rq and rq implies pj for some resource rq. Okay, like this we are going to implement the single instance of each resource type. So next one is deadlock recovery. Okay, that we can say recovery from deadlock. Okay, how we are going to recover the deadlock? When a detection algorithm determines that a deadlock exists, several alternatives are available. There are two options of breaking the deadlock majorly. One is simply to abort one or more processes to break the circular wait condition. The other is to preempt some resource from one or more of the deadlock processes. Okay, these two are the major recoveries. So first one is process termination. In this process termination, we are going to talk about all deadlock processes, and next one is about one process at a time until the deadlock cycle is eliminated. So next one is resource preemption. In this resource preemption, we are going to talk about selection of victim process, a rollback, and the next one is starvation. Okay, so whereas coming to process termination, first one is about all deadlock processes. In this one, we are going to terminate all deadlocked processes which will break deadlock immediately, but if it is a bit expensive, because there may be some processes which have been executing for long time, consuming considerable CPU time, and their terminate on will result in wasting of those CPU cycles. Okay, so this is regarding about all deadlock processes. Okay, next one is about one process at a time until the deadlock cycle is eliminated. In this one, what will happen is, in order to overcome the drawback of above method, that is first one, this method terminates one process at a time until deadlock is recovered. However, it has some overhead, since after terminating each process, detection algorithm has been has to be executed for deciding to further terminate the processes or not. This method is this is not the correct slow, we can say it is the slower method when compared to first one. Okay, so next one is resource preemption. So in this resource preemption, first one is selection of victim process, next one is rollback, next one is starvation. So in this method, resources are deallocated or preempted from some processes and the same are allocated to other until deadlock is resolved. We have three important issues, that is first one is selection of victim process. In the selection of victim process, we need to decide which process or which resource are to be preempted. The decision is based on cost factor, which includes the number of resources a deadlock process is holding and the CPU time consumed by it. Whereas next one is rollback. So in this rollback, the process which was preempted cannot continue normal execution because its resources are taken back. Hence, we need to roll back to some previous checkpoint or total rollback to start it from the beginning. Okay. Whereas next one is starvation. Whereas in the starvation, we should ensure that a particular process should not starve every time a preemption is done. Okay. So this is the recovery from the deadlock. Okay. So all these are the recoveries from the deadlock. Okay. So this is regarding deadlock detection and deadlock recovery. Okay. So in this concept, in this deadlock concept, we are going to completely talk about what is a deadlock. See how the deadlock can occur. So what are the major characteristics of a deadlock? So at the same time, what are the necessary conditions of a deadlock? Next one is purely concentrating on the methods for handling the deadlock. In the methods for handling the deadlock, first one is deadlock prevention, deadlock avoidance, and deadlock detection and recovery. In first one, deadlock avoidance, in the deadlock avoidance, we are going to make the four conditions as any one false. Deadlock avoidance. Next one is deadlock prevention. So next one is finally deadlock detection and recovery. In this recovery, we have two strategies, that is process termination and resource preemption. Okay, this is regarding deadlock concept. Okay, thank you.